Infrared spectroscopy. All it is, in essence, is identifying bonds in a molecule due to them absorbing different frequencies of infrared. Now with NMR, we have absorbance up the side, and then we effectively have frequency on the x-axis, and we have peaks, don't we? However, again in chemistry, they don't make it simple. We do it in terms of transmittance, which is the opposite of absorption. And on the x-axis, yes, it's essentially frequency, but actually it's done in terms of wave number. And the unit of that is centimeters to the -1. In other words, it's 1 over wavelength, which is in essence a measure of frequency. And so because it's transmittance that we're measuring, we're not going to have peaks, but rather we're going to have troughs. We still call them peaks, but they go downward. When we have a peak, that shows that there is a particular bond present in a molecule and it is absorbing a certain frequency, certain wave number of infrared radiation. Here's the table of bonds to wave number ranges. So here's the IR spectrum for a particular molecule. We want to know what it is. First off, we have a peak at around 3000. That's going to be our CH bond. And that's going to be one that crops up a lot. We have a peak at about 1700. What's that going to be? Well, it's just outside the C double bond. So therefore, it looks like it's going to be our C double bond O. And then we have all this mess over here. Now, this is what we call the fingerprint region. And this is specific to the molecule. Now you can reference it, but if you're going to use this, you need to look at known spectra to compare to this to find out what it is. But we can use 500 to 1500 centimeters to the -1. But it's not only about what we see in a spectrum, it's also what we don't see. Now we don't see a significant peak between 2500 and 3000, so it's not going to be OH for an acid. We don't really see it for alcohols either. So it looks like it's probably going to be an aldehyde. Now, without knowing what the molecular formula is, we can't know anything else, really, unless we look at the fingerprint region. It could be ethanol, propanol, we don't know. So this allows you to identify functional groups. And so it is a lot easier than NMR, but NMR does give you more information. But we can use these analytical techniques along with others and build up a picture of what a molecule is. As per usual with analytical techniques, it is all about getting that practice in and starting to recognize the common peaks that we have in these infrared spectra. So I hope you found that helpful. If you did, please leave a like. And if you have any suggestions on what I can do next, then put it in a comment down below. See you next time.